Hello, my name is Janvi Rajnikant Patel, and today I'll be presenting my project on analyzing the impact of the traffic volume on air quality in New York City. This project is done under the course of a Data Analysis in Construction Management CNST 6308. This project investigates the relation between traffic volume and air quality in key areas of the New York City using traffic data from New York Department Transportation NYC dot and air quality data from Environment Protection Agency EPA. So, before I start, I would like to take a moment to thank to my professor Dr. Liu Gao for his valuable support and guidance throughout this project and throughout this course. So his help has been crucial to complete this project as well. Now, let's quickly go through the table of a content for today's presentation. I'll be starting with the objective in which I will tell you the key goal and the research focus, then introduction, methodology, data analysis, other influencing factors, and conclusion. So, objective of the study. So, the main goal of the study is to explore how traffic congestion influence the air quality, particularly in high traffic zone like Brooklyn Bridge, George Washington Bridge, and others. By analyzing the key pollutant like PM 2.5, nitrogen dioxide, and ozone, I aim to identify the pattern to provide the actionable insight for improving the urban air quality and improving the living. Now let's go through the key step that involved in the data analysis process. So started from installing the pandas, import the pandas, load the data, inspect the data using df.head, clean the data using dropna and fillna function, manipulate the data by filter some row, create the column and combining the data, analyzing the data and then visualizing the data. Let me also show you the codings which I used. So like I say, I started from import the necessary libraries and load the necessary files. Then I started the data cleaning process in which I merged the data, I dropped the unnecessary columns, I convert the date column into the dateline format, and then I started the data visualization by using the functions like a plt.figure and etc. So these were the key steps for data analysis. Now in this slide, I will examine the relation between the traffic volume and the air pollutant concentration. The analysis focus on the three key pollutants. First is ozone at E03. This pollutant exhibit the highest concentration value ranging from 40 to 70 mg per meter cube across the various level of a traffic volume. As traffic volume increase, ozone concentration also tend to increase, which highlight the role of the vehicular emission in ozone formation. Next, if we talk about the nitrogen dioxide, concentration of NO2 varied from 5 to 30 mg per meter cube, with the traffic volume ranging from 20,000 to 180,000 vehicles. This indicate the moderate relation between the traffic density, and nitrogen dioxide levels. Through the other factors such as weather condition may also play a role. Now, if we talk about PM 2.5, it was relatively very stable, ranging from 0 to 20 μg per meter cube, with minimal variation in despite a change in the traffic volume. This suggests that the other sources of particular matter, such as industrial emission of a residential heating, might influence PM 2.5 level more significantly than the traffic volume. These insights were derived by analyzing the traffic data and pollutant over different time period and a different location. Visualizations such as scatter plot and time series graph were created to understand these patterns. You can see the matplotlib lib.python was also used. Now, let's talk about the temporal analysis. So, this visualization was generated by using Python library like Matplotlib and Seaborn, which allow the plot and the relation, which allow us to plot, which allow me to plot the relation between traffic volume and the air quality. So, on this slide, I have examined the seasonal and the temporal patterns. So, let's talk about the ozone. Ozone concentration exhibit distinct seasonal variation, peaking during the summer month. During this period, ozone level was reached around 17 μg per meter cube. We can see this here. Now, during the period, ozone level can reach 70 μg per meter cube. It was because of the higher temperature and increase in the sunlight, which promote the ozone formation. In contrast, during winter, ozone concentration drop between 30 to 35 μg per meter cube. As the cooler weather can and reduce the sunlight limit zone limit the ozone production. If we talk about the nitrogen dioxide had showed the different pattern. It was a higher in a winter with the concentration ranging from 15 to 20 μg per meter cube due to the fuel combustion for heating transportation during the cooler month. And during the summer, NO2 level was a lower ranging from 10 to 15 because traffic pattern may change. There is generally more efficient air circulation due to warmer temperature. PM 2.5 remain relatively very stable throughout the year with the only slight seasonal variations. The pollution concentration typically fluctuate between 5 to 15 μg per meter cube, suggest that PM 2.5 is less affected seasonal temperature or less affected pollution in the seasonal temperature also. In this slide, I'll be presenting the correlation analysis. So, if we talk about the correlation findings, the correlation coefficient between traffic volume and air quality was 0.06, which indicate very weak positive correlation. This suggests that traffic is not only the alone factor influencing the air quality. If we talk about the pie chart, it demonstrates the distribution of average air pollutant concentration in New York City, with the highest of ozone, which is 66.3, 24 for NO2, and for PM 2.5, it's 30.2. In this slide, I will be presenting the K-means clustering for both air quality data and the traffic data. K-means clustering used to analyze the hourly variation. The clustering technique helped to identify the period of a high, moderate, and a low pollution. So the clusters are defined as a cluster 0, cluster 1, and cluster 2. Cluster 0 include when pollution concentration range from 40 to 100 μg per meter cube, typically observed between 10 to 8 p.m. This indicate higher pollution level are associated with the peak hour of the urban activities in the traffic. Cluster 1 shows the moderate pollution. This cluster shows the concentration between 60 to 100 mg during the early morning hours, 12 to 10 a.m. This suggests that while pollution level are moderate during this time, and cluster 2 is shows the low pollution concentration in this cluster is from 0 to 40 mg per meter cube, typically during the off peak hours. So, talking about the coding, these particular programs were used for finding the k-means clustering. Such as k-means is equal to k-mean df underscore clean cluster, etc. Now, if we talk about the regression analysis and F1 score, the R square value was 0.0043, indicating that traffic volume explain only 0.43% of the variance in air quality. This suggests that traffic volume alone cannot reliably predict the air quality level. This residual plot shows the significance prediction in the error. Now, talking about the F1 score of 0.8571 indicates that the classification component of the analysis, particularly identify the period of a high versus low, was performed very well. This score suggests a good balance between precision and the recall, the regression, despite the regression model's limitation. Now, if we talk about the other influencing factors, the weak regression result, the regression analysis showed the very weak correlation. So between traffic and air quality, and this suggests that traffic volume cannot alone explain the majority of the variation in the air quality, and the other external factor play more significant role. Talking about the external factor, first can be the meteorological condition such as wind pattern, temperature variation, precipitation, humidity play the significant role. How pollutant are changed, either trapping or spreading them. Uh, Talking about the urban environment, building destiny, industrial emission, urban heat island effect also contribute the air quality. Now, talking about the regional influences, the pollution from surrounding area, industry activity, agriculture, and marine aerosol from nearby coastal region also can affect the air quality. Now, if we talk about the reason, which is COVID-19 pandemic, I guess this can be the main reason because of the data was selected of 2019, 20, and 21. It was a COVID period, so it maybe reduced the traffic during the lockdowns, which led to temporary improvement in the air quality with the lower emission pollutant like NO2 and PM2.5. Now, industrial emissions. So, local industry contribute significantly to the NO2 and PM2.5. So, for the NO2 and PM2.5, industry can be the reason. So, increased in the industrial activity can lead to higher concentration of this harmful emission. Now, if we talk, let's go to the conclusion of the project. The analyze show the weak correlation. K-means clustering identify the high, moderate, and low traffic based on the time of a day and urban activity, and ozone level peaked in summer and PM and 2.5 higher in the winter. While traffic influenced the air quality, Weather in condition, industrial emission, and the urban layout play a significant role. This study is focused on the volume as a primary predictor, ignoring other variations like socioeconomic status and the land use pattern. So, future study should expand to include the additional factors such as weather, industry, and machine learning. Thank you all for your time and your attention. I hope this presentation has provided you with the valuable insight into the relation between air quality and the traffic volume for the New York City. A special thank you to my professor, Dr. Liu Gao, for his guidance and the support throughout the project. His help was the instrumental in the shaping the analysis and the ensuring the success of the project. As a civil engineer, I learned a lot about the coding with the help of this course. Thank you.